in the notice, yeah, I posted the Kaggle competition, but it's 1 out of the 3. So that means we are going to have 3 competitions altogether. So just copy the URL here. So let me copy and put it on the chatting so that everybody can see. So once you click the URL, you will be directed to the Kaggle site. And I can see my competition. The first one was the Kaggle practice competition. So I let you know how to join in the competition. And this is the financial engineering competition, the first one. So we are going to have the competition very similar to this one, but this is going to be the easiest one. So I posted this competition yesterday, but and yeah, there are already two persons who joined the competition. So in order to join this competition, you need to accept some rules here. And the description is really short. So this is the first out of the 3 consecutive regression challenge competitions. And it is the easiest one in the sense that we have a complete data set. So here I gave you the older data set, and what you have to do is to use all those data and to predict the column 5. And the due date is December 22nd. So let me go to the calendar. This is the due date, just 1 day before the Christmas Eve. So on this date, your final will be over already. So I think, yeah, you will have lots of time to finish this competition. Okay, let me take a look at the data set first. So there are basically 3 files. So the first one is the train.csv, the second one is test.csv, and the final one is the submission.csv. So what you have to do is to make a prediction for test.csv file. But in order to train your model, you need to use the train.csv. So let's take a very brief look how this data set is composed of, what kind of columns are available here. So in the train.csv, the first column is ID, and column 1, 2, 3, and 3, 4, 5, and 6. So the target in this competition, in this data set, is actually the column 5. So there are lots of different values, and you need to make a model based on the other 6 columns. So from column so with column 1, 2, 3, 4, 6, and 7 to predict the column 5. So once you train your model, then you need to solve the test.csv. You need to load this test.csv. And this is very similar, but there is no column 5 here. So what you have to do is to use all the other columns to predict the column 5. And once you are once your prediction is completed, then make a submission file, and the submission file looks like this. So there is an ID. So it's 2, 10, 13, and this ID corresponds to the ID in test data set. So you can see in the test data set, the ID starts from 2, 10, 13, 20, and submission, it has exactly the same order. And then there is a column 5. So in this example submission file, I make a very rude predictions that every number I predict the 0.01, 0.01, 0.01. And this is the baseline. So when I go to the leaderboard, and there are already 2 students who submit their competition, the submission, and this selected row is the score is 0.21. And I think, yeah, this is the minimum, because you just need to submit the file which is in your data set, then you will get exactly this number. Okay, so what this number means, it's basically root mean squared error. So it calculates the difference between your prediction and the actual value, and then square them, and then make the average of them, and then take a square root. So that's the meaning of the root mean squared error. Oh, so that is the basic the introduction to the competition. And let me take your questions. Okay, when will the other 2 competitions will be uploaded? And I hope I uploaded the second one in the next week, and the third one on the week after that. So there will be 3 competitions. And I hope that the first competition is, you should be able to finish the first competition very successfully, because as we move on to the next competition, the data set might be incomplete. So you need to know how to deal with the missing values and some missing columns. So you have to participate in all 3 competitions. Yes, that's right. So the first one is the easiest one. So I hope that everybody can get a very good score. And then the next one is a little bit more difficult. So if you cannot succeed in the first competition, you will not be able to the second competition, because the second one is more it's more complicated than the previous one. And the third one is the hardest one. So yeah, that's right. So it's about the constructing the model with a given table. So you said table, but I would prefer to say the data set. So you have your training data set, and training data set has the target value. So in order to predict that target value correctly, you need to make a model, and your model should be able to use the other columns to predict the target. And then once your model is trained, then you use the same model to predict the test data set. And test data set does not have a target value. So your job is to predict the target value for the test data set, and then submit the submission file to the competition. Then I already got the solution file, so the computer will calculate calculate the mean squared error between your prediction and my solutions, and then your score will be based on that score. So in this case, smaller the better, because that's the error. No. So what we did last time, I did not show you all the details, but I will show you all the details today. The last time our target value was MPG, and I showed you just use one columns. That's what we did in the last time. But I'm going to show you, I'm going to show you with our competition example, how can we make the prediction based on other 6 variables. So we are going to use all the other 6, 5. I'm confused. Let me go to the data. So ID is actually useless one, and it just identify the column, the rows, the location of the rows. So we have altogether 7 columns, and the column 5 is the target variable. So the other 6 variables are independent variables. So we are going to use other 6 columns to predict column 5. Yes, it's error. So your job is to try to minimize the error. So it's better to get a lower score. So the lower your score, the higher the higher your rank. So the number 1 students get the lowest mean squared error. Actually, uh, I will see your rank for each competitions. So since the first competition that we have today is the simplest one, so maybe I can give the little weight on the first competition. So I hope everybody can successfully do the first competition. And for the second competition, uh, is a little bit more difficult than the first one. So uh, I think that the your final competition is the most important competitions, because in order to get be highly ranked in the third competition, uh, you should be able to do very well on the first and the second one. So that's my guess, but I think it's not just the average. So what I'm trying to say is I'm focusing on the final, the third competitions. But the reason I made this one as a 3-step is that if is this if I make the 2 difficult competition and in one place, then lots of students cannot do that very well, and there is no way to differentiate your ability. So I made the easy one, the medium level, and the highest one. So the students who can get a high score in the most difficult one should be able to get a good score on the easiest one. So that's the reasoning. So yeah, so I don't think I have to answer this one because the weight is I value the last uh, competition more valuably. Uh, uh, you can submit uh, 10 times a day, and then you can submit every day until the finish of the competitions, and your score will be based on the best uh, best score uh, out of your all your submissions. So you can revise it uh, anytime before the due date. Time is not important. So I think this student says so. If somebody submit the earlier than the other students, and it doesn't matter. So so it's possible that on 23rd, the last day, the one student submit the all three competitions, and then he will get in the rank one. That's possible. It's for a higher rank. No, 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 no. Yeah, the rank will be based on your mean squared error, and I think if two, uh, it's very unlikely, but if two students' scores are exactly the same, the only one will be ranked on the above the other students. But it's very unlikely to have exactly the same error score unless you submit the exactly the same submission files. And so the last time, even if we use the same model, your prediction is going to be a little bit different every time you run your uh, every time you train your model. Uh, I will see. Yeah, I cannot say that. Yeah, this is the A. This is B. Yeah, at this time. It is at this right now. But I will see the distributions, and I think if you are uh, willing to take some times on your project, on your competitions, I'm pretty sure you will get an A plus. Uh, okay, let me say in this way. Okay, let me go on to the leaderboard, and this is my baseline. So you see the score is 0.21. And if your submission is below this one, you will get an C. Yeah. And if you never submit your submission, then you will get an F. And if your submission is below this number, then you will get an C. And above that, well, if only these two students are available right now, then I would give them A plus together. But you can see the number is 0.5, 0.05, 0.08. But if your score is say 0.1 or 0.2, then you will not get an A because compared to the other students, your score will be too low. Your error is too big. So that means you did not train your model very well. So I cannot give the good grade for that students. Okay, so I think you are very good. You have a you have a good understanding about what competition means. Oh, another question. The best score is actually 0. So, uh, so here is the rank, and here is the score, and the best. If your prediction is perfect, that means there is no error. You predict the exact value, then the exact value. So the actual value minus your prediction will be 0. And if you square the 0, then you get another 0, and average them out will be again 0. So the best score is 0. So in that sense, well, it's very hard to say that it's 5% error, but this error is better than this error. Is the 3 competitions final for this class or just practice for the final? All 3 competitions are for the final. So there is no practice anymore. So I'm going to judge you based on 3 competitions. So of course, here I'm going to weigh I'm going to make the biggest weight to the 3rd competition, but there will be a certain range that lots of students are very similar to each other. Then in order to make a rank for those students, I'm going to use the 2nd competition and the 1st competition. So for the competition, so that's the what I'm trying to say. Yeah. Oh, sure. So for the rest of class, for the rest of semester, I'm going to show you how to use how to do that competition in Kaggle notebook and again. Of course, today I'm going to show you I'm going to repeat the regression example, and then maybe next week, I'm going to show you how to improve a little bit of your model with different technique. And then the next week, I'm going to show you another technique that might help you improve your rank. So every week, we are going to do mostly the same problem. So don't worry, just attend our meeting and then follow what I am doing with you. Yeah, if your submission get 0 score, that means yours are completely correct. And if you get 3 zeros for the all competitions, you are absolutely A+. But you see, that is going to be a really hard one because I tried my competitions when I make this problem set, and when I trained it, usually it takes more than 30 minutes to train 1 times. So I don't know. You're so smart that you can make the perfect predictions. Yeah, you can see the rank too. Yeah, but actually that rank is there is a two ranking system. So one is public. That means you can see the other students' score, but for me, I can see the private leaderboard, so which can be shown only to me. And the difference between these two is that, okay, this leaderboard is calculated with approximately 50 of the test set. The final result will be based on the other 50%, so the final standing may be different. And that's true. And there is a reason why I have to split into two different the leaderboard. So, okay, let me say you in this way. Okay. So you may think that my problem is actually this. So this is 2, 20, 30, 35, and so on. And this is going to be your submission file. And there is a way to cheat. So this is the a way to cheat the computer, but the 50% and 50% calculation prevents that kind of cheat. So for example, I'm gonna make everything as 0.1. And then you submit your file, then your score will be calculated, something like this one. And then after that, you change just one number. And then, I don't know, it might be some other numbers. And then you change the other numbers. Then it will gives you some other numbers. And then every time you change a number, your score will be changed. And based on that information, so this is a cheating, but if you can, you can cheat if you are able to do that. So by changing all these numbers, every time you will get a different scores. So maybe maybe you can find the perfect value for each one. I don't know how to do that, but maybe you can find perfect value for each one to get score 0. But that will not work because I have another 50% of the problem here. So, and this one, you cannot see this other 50%. But the data set is divided into very randomly. So if you use the other column values to predict your one and other column values to predict your one, and if your model is pretty smart, then you should get a very low score, say 0.1. And then this model should also work for the other 50% because this is the really good model. So this is the way to prevent the cheating. So that's why there is a two board, but I can see the both of them, but you can see only the public leaderboard. But if your model is good enough, then usually the score you will get is very similar to the public leaderboard score. So it's 0.05, it's 0.08, and in public score is still 0.05, 0.08, but the last digits are a little bit different from the public leaderboard. Okay, no more questions. So let's go into the Kaggle competition. And before that, I want to show you the TensorFlow And we are going to go into the get started with TensorFlow and tutorials. I think there is another question. Yes, it is correct. So you don't know the cut for the grade, and you don't know how many students get A, B at this moment. So the grade will be decided after all three submissions, yeah, based on the distribution of each student. Yeah, that's right. But I think it was in the first meeting, I said the last semester, last year, more than 80% of my students get an A+. So I hope that will help you. Okay, we are in TensorFlow Get Started tutorial, and here is a machine learning basic with Keras. And there is a regression, and we can run. So basically, what you have to do is just to use this code in your competition. That's it. So let's make a notebook. And I'm going to make a new notebook. And it's Python, and type is notebook. And I will create my notebook. So in order to use the data set, you have to participate in this competition. And then inside that competition, you press the new notebook. In that way, you can use the files. Other than that, you cannot see these three files. So the submission file is here, and test set is here, and train set is here. I don't know how to full with table. I don't know. I don't need these tables anymore. Okay. So the first cell is automatic. So you just press Shift Enter. Then you will get the directory. You will get the location of your three files. And here the NumPy and Pandas are already imported. So let me read our file. So df pd dot read underscore csv, and I'm okay here. I want to read the submission file first because I want to test that my submission is correct or not. So this is the way we can read the submission file. So it's pd.readcsv and your location. And of course, you have to write the quote sign here around the location. And then df, then you will see the ID and columns. And it has all 23,520 rows. So that's what you need to predict. So currently the prediction is all 0.0, 0.01, 0.01. So I'm gonna make a submission file with that. So how can I make the submission file? So currently the DF is a Panda data frame. It's not the the CSV format file. So in order to save it, so df dot to underscore CSV, and then you need to write down the submission file. So it's submission.csv. And one more thing you should do is that index is equal to false. And then it will be saved here, because on the right hand side there is an input folder, but there is also an output folder, and you can see the submission.csv. I don't know, I cannot see this one, but anyway, yeah, there is a submission.csv. And I think this is not fun at all. So maybe instead of doing this, let me, so okay, this is tier 5, and let's say I want to change my column 5 is, say, 0.1. And if you see your data frame, now it's all 0.1. It was originally 0.01, but I just changed it to 0.1. And then I'm gonna save it to CSV, and then say save it to the same name, submission. And if you save it again, then it will be overwritten. So submission dot CSV still index is equal to false. And in order to make a submission, okay, how to find the path of the data set one more time, okay? Okay, let me go out of this one, and I just leave the editor. Okay, first thing you have to do is to follow the URL that I gave you in the YSEC. So it's simple. kaggle.com/c/2020-10-29. It was yesterday, and then you should be here, the financial engineering competition 1/3. And I think there is a button, join the competition or something similar to that. And then you have to join the competition and accept the rule. And once you are inside the competition, then here is a notebook. And then you can make a new notebook. And then leave everything as it is, and then create. Then the first cell is automatic. So you just press this arrow button or press Shift and Enter. Then you will see 3 different paths. So I'm going to read pd dot read CSV and make a quotation mark, and I'm going to read this submission.csv, Control V, and then I want to see what's inside. And this is my submission file. And then I know there is a ID column and column 5 column. So I'm gonna make my column underscore 5 to be, say, 10 this time. And if I see my prediction, then everything is 10. And then I need to save it to CSV submission CSV and index is false. Okay, then in order to make a submission, you need to save your version right on here. So save a version, and this is version 1. So I'm gonna make 1.0, and it's optional, so you don't have to write it. You don't have to write anything, whatever you want. And then I just wanna save and run all. Then it will save my whole notebook, and then it will run my notebook from the first until the bottom. Okay, once it is done, you can press the view button here, or you can press the show version button here. And this is your version, and then go to the viewer. And if you want to make a change, then you can press the edit button. But I just wanted to show you how to submit. So here is a notebook, and here is an input section, and here is an output section. So if you scroll up or down, you can see lots of things are moving. And what you have to do is go to the output section, and there is a submit button. And as you can see, since I changed all my value to 10, my prediction is all 10, and I'm going to submit. Then it says you have 10 submissions remaining today, and submissions reset daily. So that means you can submit 10 times a day, and then the tomorrow you can make another 10 submissions. So I'm gonna submit. And I can see my submission by pressing view my submission, and check that your submission is complete. And then once you are successful, you can see your rank in the leaderboard. Yeah. So this is terrible. Because I made a very terrible predictions. So the students get the not good one. So why don't you try another one? So okay, public leaderboard. Okay. So let's take a break, and we will be back at 3 p.m. And what I'm going to do is to just follow the TensorFlow example, and this is just, yeah, copy and paste to our problem to get a better result. By the way, I want to let you know that uh, I'm going to invite the students from my other class to join in this competition also. So the total number of competitor will be around 250. So don't be surprised that there are so many competitors. So I'm going to start, yeah, from another notebook. And it's okay, you can, yeah, start with your own notebook. I mean, your previous notebook, but I just wanted to start it again. And I'm going to, okay, so since I have, yeah, another screen, so I'm going to write down the import TensorFlow as TF, and also I wanna import, from TensorFlow. My typing is too slow, so I'm going to copy and paste, yeah, for this one. So we import the TensorFlow, and then from the TensorFlow, we import Keras. And from TensorFlow Keras, we import layers. And from layer experimental, we import pre-processing. And I'm going to make very similar to the one we can see on the TensorFlow website. So it's, first I'm gonna make a low data set is PD read CSV, and my train data set. And then my data set is low data set dot copy and data set dot tail. Then I can see some of my values at the end. And actually there is no missing value here, but just for make sure that is there any missing values. And you can see there is no missing values. Is NA means that there is to make your cell to be true or false, whether depending on whether there is a value or not. So there is no missing value. So we don't need the drop, and we just make the train data set and test data set here. The split the train data set is going to be the data set that sample, and fraction is 0.8, and random state is 0, and my test data set is dataset dot drop train dataset dot index. So let's see what's inside my train dataset. So it has 25,000 rows, and in my test data set, I have 18,000 rows. And I'm going to skip the drawing, and I'm going to splitting the data, splitting features from labels. So train dataset copy is going to be my train features, and then I'm going to take and then make the test dataset copy to test features, and I'm going to take out not the MPG because my target value is column 5. So instead of the MPG, I'm going to say column 5, and then here column 5. Okay, so my train feature, there's no train feature. Yeah, there's no train feature because it's train features. So the column 5 is gone, and train, what was that? It was train labels. Train labels is the target variable we are going to predict. So maybe, yeah, I can skip the normalization at first, and then I'm going to go straight to the BNN regression. Oh, there is a question. Low data set is not defined. Yeah, first you have to read your raw data set first. So from here, you need this line, because first you have to read the data set and then save it to raw data set. But it's okay if you use the different names. The second line, one more time. Yeah, I think, yeah, I'm a little bit fast, but what we are going to do is just make a copy from the TensorFlow website and then bring it here. So yeah, let me see another. Yeah, I can do that. Yeah. Okay, frac, and so we read the data set, and here is a frac 0.8 and random state is 0. And this is okay. what do you think it is? So it's a data set and then sample and frag is 0.8. That means I'm going to take a sample from my data set and the fraction is 80%. So that means I'm going to take 80% from my original set. From my original set, I'm going to take 80% of them and then put it in a trained data set. So this is a quite random choice, but in order to make the same result, we can set the random state as some number. So here we use the number 0. So that kind of number is usually called the random seed. So every time we take the random sample, the result will be different from the previous one. But in order to see how accurate we are, so we sometimes make the seed as some fixed number, so that every time I select exactly the same sample. So that's the meaning of the data set sample and fraction is 0.8. So if I wanted to just take the 70% of them, then I can change it to 0.7. And the random state, I can choose whatever number I like. So even if I change this part, everything is still the same. Syntax error can assign to operator. Okay. Can you copy your syntax, your code, and put it in the chat? And for other students, yeah, who can follow me so far well, then just make some experiments with the TensorFlow code after train data set. Okay, after train data set. Okay, here was it. Train data set, and then later is this one. Okay. Let's do it in this way. So first, the first cell should be same as mine. And then I'm going to make a copy of everything that I write in the chatting, so that you can make a copy from the chatting and then copy the things from the chatting and put it in your Kaggle notebook. Then I think everyone can follow exactly the same thing. So on the chatting, this is how to read the data and make a copy. And then we check that the data is all available. And then I take, in this case, 70% with the random state 999. And then I think I can, skip this part because it's just, check everything is okay. So for you, this part is needed. So we make a copy of the train data set into train features and copy of the test data set into test feature. And then the pop means just take out that column out of the original from the train that features. So I check that everything is all right. And then I build a model. So the model is here. So how can we build a model? So it's a function. So we start with the DEF, and this is the function name. And it has a norm. So, but I don't want to use this norm right now. So I'm just erase my part, and I'm gonna put it again in the chatting. And it has 3 layers. So the first one is a dense layer with 64 nodes. The second one is another dense layer with 64 nodes. And the final one is just a layer with 1 node. And here our loss is mean absolute error, which is different from ours. But for right now, we just use the mean absolute error. And then the optimizer is set to TF Keras optimizer Adam. So this is our model. And then we can see, we can make, let's say DNN model is build and compile model. And then I want to see what's inside the model. So DNN model dot summary. So there is some error. I want to see. Build and compile model, DNN model, summary. Oh, okay, I see. Yeah, what's wrong? It's a dense 64, and then input shape is 6. Yeah, I think it will work. So I'm gonna send you again. So input should be 6. Yeah, I think this is correct. And then I'm going to train my model. So train feature, train label, validation split, verbosity. Okay, let me see. Just a second. I want to see what's wrong with me. Let me try another one. Train features. Train features. Ah, I see. Yep. Okay. I see. What was wrong? So maybe top ID. So it's okay. It's okay. Non-type object is not callable. Start. Maybe I can change it to MP array. Well, it happens all the time. And this is why we need lots of time to figure out what's wrong. It's train features, train labels. Make it simple. Non-type object is not callable. Hmm. Input shape is oh, so the problem was here. Oh, what did I wrong? Input shape was 6. Hmm. I don't know why it was an error. Input shape 6, and activation. Maybe. Okay, I fixed the problem, but I don't know why. Yeah, that there was a mistake. I just make a copy my model again, and then send you. Okay, I think it will work. And then the next part is this, and oh, you also need this. And then this. Let's see. Then it will work. Okay. I spent too much time. Okay, let me. So we exclude CD norm from the depth build. Yes, that's right. So maybe that was the mistake that I made, the one of the reason. But I just wanted to show you the most simplest way to build the network model. And in this tutorial, there is a norm, and norm is defined in another way, but I just wanted to skip that part. So in the definition, we exclude this part. Yeah, that's true. And 16 to 8 columns again. I don't know where it is, but I made all the necessary code in the chatting, so you may refer to that. Oh, you didn't show an error, yeah. But for me, yeah, for some reasons, yeah, I made a mistake. Okay, train features pop ID. So, okay, let me explain, what was wrong. So when I built the build and compile model, uh, there was a argument norm here. but I wanted to show you it can be run without this part. So I erased this part, and I also erased the first norm part. So norm is gone, and then the problem that I saw is that I did not specify how many columns we will start. So I add this part, and then when I build the other part, okay, the first, I thought the column number was 6, but actually it was 7 because there was an ID column. So I just take that out. So that's the train features pop ID. So do you remember the pop means to take that column out of the place. So by taking out the ID column, now my train features has 6 columns. So now, I change this to 6. So so this train features pop ID can be anywhere just before the fit. It can be anywhere. Because in fit, we are going to use the train features as our X and train label as our Y. But since I set my model that the input is the input column is 6, but it was actually 7. So there was an error. So I fixed it by taking the ID column out of that. So you can add anywhere before the fit. Yeah. So I will share. Okay. Okay. One way of handling this is that I can share the code itself. I can make it public, and then I'm going to share with you. Then you can go to the Kaggle and go to the competition. And in the notebook section, I can share with you. I think you should see this one. Okay. Make a copy and put it in the chatting. So now I think you can see the version that I share. Okay, I share the notebook. So please go to the shared notebook, and we are going to start from the first again, so that you can just make some adjustment. Okay. I get a error. Okay, yeah. Yeah, I share it. So can you see my shared notebook or uh, um, do I need to share it again? Make it public. I think this is the same one. Yeah. So let me see, I can see my shared version. Okay, can you tell me you can see my shared version? It's a hard drive, it's a CPU, and it's a random access memory. So please anyone let me know you can see my shared version. If you cannot see, yeah, please, yeah, say no. And oh, okay, okay. Okay, I see. So I'm gonna, but it takes too long because when I wanted to save it. So maybe I can make this part. Okay, save version. Oh, okay, that's good. Yeah, it is sharing. Oh yeah. Okay, so you can see my notebook, and if you wanna edit, then there is an edit button. Okay. So we can all run the first cell, and that's just a listing of the cells, the files. And then we import TensorFlow, and then read the file and check whether there is a missing column or not. And as you can see, there is a ID column. So that was my mistakes. I forgot there was an ID column. But anyway, we take the 70% of the sample and we are going to start from state 999. It's just my number. And we can see the train data set and test data set. And then we did something, pop, but I did not, took out the, I did not take out the ID. So I take out my, okay. So you should, make the adjustment here, because if I took out the ID from the train, I should have to do the same thing for the test. So maybe I need to write test features dot pop ID. Okay. Change. Yeah, it takes a long time. Yeah. To not pop out and change the input shape to 7. Okay, that is also possible. But the problem is if you use the ID column, that ID column is actually not related to the output. It is just a unique values. So your model will be much more, it works much worse than without the ID columns, because for the other columns, there is actually some relationship to the column 5, but for the ID column, there's no relationship between the target and the ID, because that's just the ID. So I hope, everyone pop out the ID from the test data set also. And I just wanted to make sure, no, not make sure, I just wanted to see. And then here we are building our model without norm. And the number here is 6. So the students that the last question was without taking out the ID column, we can make it 7. And that's correct, but that might be not good for your models. So we can do it at 6. And then see the summary. And the dense 15, 16 might be different from yours. It's just a sequential number. And then train features info, I just did it for check that everything is all right. And then the last, the cell erase the comment so that it actually runs. And the 100 takes too long, so I'm gonna make it 10 so that I can see the result. So as I said, the data set is pretty big, so it takes some time. So okay, now I can see the things. So we can make some predictions or something similar to that. But before that, I want to make a plot. So in order to make a plot, we need to import matplotlib. lib dot py plot as plt, and then I will give you a copy, so don't worry. Okay, this part is on the chat. And then we are going to make a chart. Okay, so since I did it for just 10 times, it's not as good. But as you can see, the loss is decreasing as we increase the number of epochs. And the validation loss is fluctuating, but it is still decreasing. And our error is about between 0.05 and 0.1. So I think it's a good start for just 10 iterations. So in order to make a submission, we need to make a prediction first. So how can I make a prediction? So this is what they said, but I don't know. Let me try and test predictions. Is not here because, yeah, test predictions. Okay. So in order to make the real submission for our competition, just below the graph, we need to import. We need to read the test file. So my test is pd read csv, and what's the name? It was kaggle test.csv. So I read this, and the problem with this one is there is a ID column here. So I have to take out the ID. Okay. And then maybe I can make a prediction. And I wanted to see what's inside. Okay, this is much better. So now I need to make a submission file. So in order to make a submission file, I need the sample submission file. So it's pd read csv not this one, but actually the submission file has exactly the same order as this test file. So I'm going to read the submission. Okay. And let me see what's inside. Okay, it's df. So I'm gonna make my df column 5 as my test predictions. And let me see. Yes, it's correct. So I need to save this df to CSV dot submission dot CSV, and the index is false. Okay. And then save the version to version 2.0, and then I need to save. And then it will run from the top to bottom again. So it will not take too long, but if you wanted to do the real thing, then you have to increase the number of epochs. Then it will really take, say, 1 hour. But anyway, I will wait here to get my result. And sure, MPG is not defined because we do not use the MPG, right? Because it's column 5 for us. The MPG. So I said that, yeah, you just need to make a copy and paste, and then you'll be fine. But actually, if you just wanted to make a copy and paste, you need to understand what was going on the TensorFlow website so that you can make some modifications. Yeah, that's what I'm doing. Actually, it's not DNN classifier, it's a DNN regression. So this one is related to our regression challenge because now I'm making my final prediction and I'm going to submit it. It's test equal. So yeah, yours are a little bit there is a problem because so you are confused with the this one. So you are talking about this part, I guess. So I'm gonna put it in the chat, or you may set this one. So it's test. So you have to understand what we are doing here. So on the right-hand side of the equal sign, we are going to evaluate something, and then that evaluation will be saved on your left-hand side. So on the right-hand side, we write a PD dot. That means we are going to use the PD, the pandas, and dot means we are going to use some method defined in pandas. And that method name is read underscore CSV. So that means it reads the CSV file, and yeah, something like that. Yeah, your graph is different because as I said, even though we take the same we use the same random state, the procedure, the fitting of the model, when the TensorFlow try to fit our model with the real data, there is still a randomness. So the graph will be a little bit different from yours. Why there is an error? So here is my the prediction, and you should read your DF. You should read your submission file first, and then save it to DF. That's the meaning of this one. So we are going to replace the column 5 in DF with our test predictions. But anyway, I see how is mine working. So I'm going to show my version and go to the viewer. And then there is an output section. And in the output section, you can submit. So I have 9 submissions left. So I'm going to submit and then view my submission. And my submission is complete. And my score is 0.07, which is much better than the baseline here. Okay, there is other students, 0.07, 0.07. So this is great. We didn't do much actually. We just make a very simple model with 3 layers, and we just try to figure out how many columns we need. And then we did not use the normalization techniques, and we did not use any fancy techniques, but we get this number, which is great. Okay. Yeah, the length is different. Okay, I see why you get this one, because you are confused with the test data set and the test feature set. So what I'm saying is that in this notebook, so at the beginning, we read the train data set, and then we split the train data set into 2 parts. The one is the test features, and the other one is train features. And we are trying to, so you are probably making the prediction on test features. But what I want you to do in this competition is to use the test data set. So you need to train your model based on your train data set. And actually, I said again, the train data set is split into 2 parts in our example. And I'm going to explain why that kind of things are needed. But anyway, once you train your model with the train data set, then you need to make a prediction on test data set, and then make that prediction, put that prediction into the submission file, and then submit it. No, not at all. So the plot is for the explanations. All you need to do is to make a prediction. That's it. But sometimes you need to know how your model works. So maybe you just make some modification in your model, but how can you know that your model is getting better? So that's why we make a plot. Okay, now I see lots of students are better than before. So in this way, we can accomplish our first competitions. So I just use the minimum structure of the neural network, but as you read the tutorials on the TensorFlow, you may feel that you need to normalize your input so that it's getting better. So that's the competition. So you are required to read some parts and improve your model, or you can just increase the number of epochs, because we just use the 10 epochs, and with that so for 10 epochs we just move to say 10 times, but the actual minimum is much it should be on the other place, so you need to increase the number of epochs. But as you increase the number of epochs, the computation time will be increased, but it's okay for us because the computation in Kaggle, the computational time in Kaggle is free. And actually, if you are trying to figure out what's going on, and you can actually use the so-called GPU, and they give you the free hour for GPU. But for right now, our problem is not so complicated. But if you want here, you can try to figure out how to use the GPU. Okay, I think that's it for today, and I hope you can do much better for your first competition, and try to do some experimentation on your competitions, because this is, so from my point of view, this is the simplest competition. And then as we move on, our competition is getting more difficult and not so easy. So I hope you can understand what we have done today. And see you next week. That's it. And if you have any questions, uh, make a question. And actually, you can ask me in Korean. That's fine. So can you submit the file a number of times, or is there a limited number of trials? You can submit your file 10 times a day. So there is a maximum number of submission for one day, but that limitation will be reset on the next day. So tomorrow you are gonna make your some modification on your model, and then try to submit your file for 10 different models. And then on the next day, you can do the same thing again and again until the final, the due date. And your score will be based on the best prediction you have submitted. What we have to do for the competition, make a prediction and submit. So that's our competition. So I don't know, can you ask me again? I don't understand your questions. I'm going to upload my notebook on our competition site. I'll try, but I don't know how to do it right now. So, but anyway, this is a good way to we can communicate. So you can make your notebook public so that the other students can see yours, or you may ask some questions on, so for example, the discussion sections, and there is no discussions, but you can make your own, you can make some questions on this one. So make a new topic. Okay, yeah. So you can make a topic, and I hope I encourage you to discuss with, yeah, several things and then answer to your friends. Oh yeah, it's on the uh notebook. Okay, so it is already, yeah, in the public domain. Due date is December 22nd, 23rd. So, uh, so this is the due date. So basically, what did we today? This is the question. Yeah. So our competition is actually what we did today. So you are already participating in the competitions. You make a model and train your model based on the training data set and make the prediction on the test data set. And you are ranked here according to your submissions. So I hope you can get a much better result. So you know, I don't know. It can be say there is a 4% error, or and actually it does not have the right unit, but we can make it as close as a 0.001 if we can look at the data carefully and use some kind of techniques that we can make it much smaller. So I think, yeah, this is pretty good start. Yes, yes. So there is a lot of mysterious things in our code. If you really look at the case, so for example, why do we have to split our train data set into train features and test features? And that actually wanted to prevent the overfitting. So what is overfitting? And that's the materials on the y-axis. And I'm gonna make some missing values. Then how can you fill out that kind of missing values? So those things, yeah, you can try to learn from the resources on y-axis. Yeah, because I did not upload the other two competitions yet. So you can see just the one competitions. And maybe next week and 2 weeks later, I'm going to upload some more competitions. But yeah, you have to finish your first competition successfully so that you can move on to the next competition. 어, 제출하는, okay, yeah, the submission is just go to the shared notebook and at the output, there is a submit button. So this is the another minimum. See, because we already did it, make it public. So you should be better than this one. So you just press the submit button and then it will be submitted. Oh, yes. Yeah. In some sense, yeah, you are done. But I'm going to see the leaderboard. So I'm not sure where you are here, but here 0.04 will be a really terrible score after 1 or 2 months, because this is just a baseline and you will get the score at the 0.0001, something like that. So you can be very accurate. So if you are satisfied with this score, well, that's fine. Then you will get B plus, because you are above the submission, the threshold value. So I hope, yeah, you can do much better. But this is B plus. This is B plus, and I think, yeah, all these students are B plus right now, because I know you are going much better. Probably I can talk, yeah, to the first competition again, but I'm not sure. It depends. The number of a trial does not. Number of trial doesn't care. I don't care about the number of trials. I hope I encourage you to try as many as possible. But the important thing is your final score. Yes, the Kaggle competition always take the best submission. So if your second one is, oh, it's not about the rank, it's about the score. So your rank will be changed even if you did not submit again. So as you can see here, uh, your rank will depend on other students. So if all the other students are above these students, and these students rank will be lower, but the score will be the same. You will always the better score will be recorded here. So the score will remain, but rank will be changed. Yeah, that's the guarantee of the B minus. Yeah, leaderboard. If your submission is better than the submission, the CSV, you are guaranteed to have B minus. So if you're satisfied with B minus, well, then that's the end of your first competition. You cannot use how I use the private leaderboard. You may think about it in this way: the actual problem is separated. So your program, your model will solve this problem, the half of the actual problem, and submit it. And then I will use your model to the hidden 50%, the 50% of the test set to calculate your actual score. So actually, you don't have to worry about the private leaderboard at all, because if you are doing this, so let me show you this. So this is the score for the half of the of your test data set, but the private score is almost the same. So I don't think, yeah, that's not the issue. Yeah, other students from there are actually more than 150 students in my other class, and they will participate in this competition also. But your ranking, it will be divided. So, I mean, I'm going to classify for the QRM class and my for other class, because my other class will do much better than you, because they are seniors, so they will do better. But don't worry, yeah, I'm gonna make the grade for the QRM class for yeah, only for the QRM class. Yeah, yes, that's right. Yeah, the submission CSV is the really the minimum. So you should not say that this is the baseline. You always try to think that your baseline is this one, the #1 student score. You should be better than this one. Try to that. No, the score, I know, in some sense, I know the answer. So I see this score is not enough. So there will be no that there is good. How would I say? Uh, I know this score is due to the very simple model. So if you try to do it better, I'm pretty sure your score will be uh, less than 0.1%. So that's the one measure for measuring how much effort you put in here. And then if your effort is above, yes, some my expectation, then yeah, doesn't matter on the rank, you will get an A plus. 아, 이렇게 점수 어 예, 그렇게 너무 신경 안 써도 되는데. 서브미션 플러스 보드보다 점수가 낮으면 학점은 C 플러스입니다. 예. 서브미션보다 낮으면 C 플러스, 안 내면 F. That's because there is a randomness. Yes. Probably I'm gonna do something more, but the principles of financial engineering will be taught like this. Oh, yeah, that's what machine learning is trying to do. The machine learning is trying to, actually, you can think about the machine learning is a very fantastic one, but actually that's how to minimize the error. So for example, as an introduction, I showed you how to classify the mask and without mask. It's simple. So there is a masked face, and there is a prediction, and you can calculate the error. And then what kind of model can reduce that kind of error. So actually, you are actually you may think that yeah, this is just a regression problem actually, but it is machine learning in some sense. Yes, I will. For the second and third competitions. But from now on, I'm gonna show you some more, yeah, fundamentals. So maybe I'm the next week I'm going to repeat this one again. But from because I skipped a lot, I'm going to explain some more about the TensorFlow, and you can use the same technique for the second competition and third competitions, but there I'm going to talk about the a little bit more advanced way to use the model. So that kind of thing will be explained from now on. And I think yeah, that's enough for today's class. So I hope you enjoyed the class and enjoy the competition. Yes, the randomness affects your score and ranking. That's true. But as you can see here, okay, let me take these two students. It's 0.04459 and 0.045. This is due to the randomness. And this kind of randomness, I can definitely say they are about the same. But I can say these two students are quite different from these students, right? So I can distinguish you very, uh, very easily. So randomness still affects your ranking. Okay, see you next week.